In this session, we are going to discuss about examples how to find out Norton equivalent impedance using method 2. For that, first of all, let's consider this example. Here we can have one independent current source and one dependent voltage source. Here the value of the voltage source is determined by the value of current flowing through this particular branch. So this is a current controlled voltage source. So in method 2, in order to find out Norton equivalent impedance, first step is we need to remove all the independent sources, and after that we need to apply a test DC voltage source across the open circuit terminals. So the first step is apply a test voltage VDC across the open circuit terminals X and Y while making or keeping all other independent sources to 0. Here only 2 ampere independent current source is available that we can make to 0 by open circuiting. So corresponding equivalent circuit is like this. Here we applied a DC voltage source across this open circuited terminals. So this test voltage VDC send a current IDC to the circuit. Considering this node, let's assume the voltage at node A is VA, which is exactly equal to VDC. So applying KCL at node A, we can write the nodal equation as all the currents are assumed to be leaving from the node. So current flowing through this branch is VA minus 2I by 1 plus current flowing through this branch is VA by 1 and current flowing through this branch is VA by 2, and this current is entering toward this node. Since all the outgoing currents are taken as positive, the incoming current need to be taken as negative. So corresponding equation is VA minus 2I by 1 plus VA by 1 plus VA by 2 minus IDC is equal to 0. We know this current determines the value of this voltage source. So it is a current controlled voltage source. So what is this current? This current is equal to VA by 1. So this current I is equal to VA by 1, which is nothing but VA. We know VA is equal to VDC. So when we are applying I is equal to VA and VA is equal to VDC in equation number 1, equation number 1 become VDC minus 2 into I. 2 into I is 2 into VA. Okay. So VDC minus 2 VDC plus VA is VDC and VA by 2 is VDC by 2, which is equal to IDC. So this VDC and this VDC, 2 VDC and 2 VDC minus 2 VDC, this entire part becomes 0. So the final expression become IDC is equal to VDC by 2. So in method 2, the last step is we need to find the ratio VDC by IDC. So from this equation we can obtain the ratio of VDC by IDC as 2, which is nothing but Norton equivalent resistance or impedance. Now let's consider another examples in method 2. So this is the corresponding circuit. Here again we can have one controllable voltage source. The value of this voltage source is determined by the current flowing through 4 ohm resistor. The first step in method 2 is we need to apply a test DC voltage across the open circuit terminal, keeping all independent sources to 0. Here there is no independent sources. So here we applied a DC test voltage VDC across the open circuit terminal. So this DC voltage will send a current IDC towards this circuit. Similar to first case, we can apply KCL at node A. So when we are applying KCL at node A, so this current plus this current plus this current is equal to IDC. That expression we can obtain. So what is the current flowing through 2 ohm resistor? That is VA, that is VDC. Actually VA is equal to VDC. And what is I? I is equal to VA by 4, that is VDC by 4. Now we can directly write, instead of VA, we can write directly as VDC. So this current is equal to VDC minus 4I by 2 plus VDC by 2 plus VDC by 4 is equal to IDC. Substituting these values in these equations, so we can simplify the expression as 2 VDC plus VDC by 4 is equal to IDC, or 3 by 4 VDC is equal to IDC. And last step of method 2 is we need to find out the ratio VDC by IDC, and which can be obtained as 4 by 3 ohm, that is the Norton equivalent impedance Rn. Now let's consider another examples in method 2. So this is the corresponding circuit. Here again we can have only dependent sources, that is 5 VL. This voltage depends on the voltage drop across 3 ohm resistor. So it is a voltage controlled voltage source. As we discussed earlier, the first step in method 2 is we need to apply a test DC voltage source VDC across the open circuit terminal, keeping all independent sources to 0. So here we applied a DC voltage that will send a current IDC to the circuit. When we are applying a test voltage VDC across the open circuit terminal, it forms two meshes. This is mesh 1 and this is mesh 2. Let the mesh current be I1 and this direction be like this, and mesh 2 current be I2, which is having the direction shown here. And it is to be noted that I2 is exactly equal to IDC. So finally we need to obtain the ratio VDC by IDC. So VDC by I2 gives Rn, that is Norton equivalent impedance. So first of all, let's consider mesh 1. In mesh 1, what is VL? The current flowing through mesh 1 is I1 with this direction. So what is VL? VL is equal to 3 into I1. As the VL is equal to 3 into I1, this voltage source 5 VL is equal to 5 into 3 I1, which gives 15 I1. As current is flowing in this direction, let's mark the potentials across resistance like this, plus minus, plus minus, plus minus. When we are writing KVL equations, let's take this order. So this is rise in potential, this is again rise in potential, this is fall in potential, again rise in potential. So the KVL equation become VL plus 2I1 minus 5VL plus I1 minus I2 into 1, which is equal to 0. Simplifying, we can obtain the expression I2 is equal to minus 9I1. Again, I1 is equal to minus I2 by 9. Let it be equation number 1. So this is plus VDC. We can mark the polarity like this when we are considering mesh 2. So VDC minus I2 into 1 minus I2 minus I1. Why? Because these two currents are in opposite direction. So the KVL equation become VDC minus I2 minus I2 minus I1 minus 5VL is equal to 0. We know 5VL is equal to 15 I1. So considering all these things, we can obtain the final expression in loop 2 as VDC is equal to 2I2 plus 14 I1. When we are substituting I1 as minus I2 by 9 in equation number 2, equation number 2 can be written as VDC is equal to 2I2 minus 14 into I2 by 9. So further simplifying, we can obtain the value of VDC as 0.44 I2. So as we know, I2 is exactly equal to IDC, And finally in method 2 we need to find the ratio VDC by IDC, so which is equal to VDC by I2. So considering this fact, we can obtain Norton equivalent resistance or Norton equivalent impedance as VDC by IDC, which is equal to 0.44 ohm.